All right, now we have question number 5. This is a question about velocity vectors. Yeah. In this question, I and j are horizontal perpendicular vectors and position vectors are given relative to a fixed origin. Okay. In a game, a ball B is rolled across a horizontal surface towards a fixed target. The ball is modeled as a particle moving with constant velocity. Okay. At time t is equals to 1 second, the position vector is so and so. At time 9 seconds, it's so and so. Find the velocity of the ball. Okay, so what is velocity equal to? Velocity is basically equal to the displacement, or you can say the change in displacement upon time. Okay, so change in displacement over change in time. So if I want to find out the velocity, I want to see how the displacement changes with the given time. So in order to find out the change in displacement, we'll take the displacement at 9 seconds, so that's 10i minus 3j. From this, we will subtract the displacement at 1 second, so that's minus 2i plus 5j, and we will divide this by the time. What's that equal to? That's equal to 9 minus 1. So 10 minus minus 2, that's equal to 12i, minus 3 minus 5, that's equal to minus 8j, divide by the time, which is 8, and then if we simplify this, what's this equal to? This is equal to 1.5 I minus j, and since it's velocity, so meters per second. And there you go, that's the answer to the first part. Now let's have a look at part B. Part B says the position vector of the target is 13i minus 5j. Use the model to find the distance of B from the target at time t is equals to 7 seconds. Okay, so first thing we need to do is we need to actually write down the position vector equation of the ball. Okay, so how will I write down the position vector equation of the ball? Here's what I can do. So in order to write down the position vector, this is the formula. R is equals to A plus V, which is velocity, multiplied by the time. Okay, so A is basically the position vector, okay, and V is the velocity vector, and T is basically time. Okay, now this question is a little bit tricky in the sense that you are not given the starting point of the ball. Okay, you're given the you're basically given the position vector at 1 second. Okay, now here's what you can do. If you want to find out where is the ball at 0 seconds, what you can simply do is you can see where it is at 1 second, and from that subtract the velocity vector, because every second it's moving 1.5 units towards the right and 1 unit towards the left. Okay, so actually let's do that. Let's find out where is the ball at time t is equals to 0. So what will I do for that? Minus 2i plus 5j. From this, I will subtract exactly how much it has moved in 1 second. Okay, so this will give me minus 2 minus 1.5, so that's minus 3.5i. 5 minus minus 1, so that's equal to plus 6j. So that means this is basically where the ball is at the starting point. So if I want to write down its velocity equation, its position vector equation, sorry, so that would be, so I'm going to prefer column vectors now, 3.5 negative 6 plus the velocity vector. So what's the velocity vector? The velocity vector is 1.5 and minus 1, we just worked it out, times t. So with the help of this, I can find out its position vector at any value of t. Okay, and what do we have to do? We have to find out its distance from the target at time t is equals to 7 seconds. So that means what I need to do is I need to find out exactly where it is at t is equals to 7. So I'm simply going to plug in 7. That's what I'm going to do. So minus 3.5, 6 plus 1.5 times 7. Let's see what that is. So 1.5 times 7, that is equal to 10.5. And minus 1 times 7, that's equal to minus 7. Let's add them up. Let's see what do we get. So as we add them up, we have minus 3.5 plus, okay, let me just make sure I've done everything correctly. Yeah, so minus 3.5 plus 10.5, that I believe is 6, minus 3.5 plus 10.5, yep, that's actually equal to 7. Sorry, not 6, that's actually equal to 7. 6 plus minus 7, that's equal to minus 1. Okay, so this is where the ball is at t is equals to 7. So we can call this OB. Now the target is 39 minus 5j. So we can call this OT. So OT, okay, this vector is 39 minus 5j. So that means 13 and minus 5. So here's what we can do. If I want to find out the distance, that means I can either do OB minus OT, that will give me TP. Okay, so OB is 7 and minus 1. From this, I need to subtract OT, so that's 13 and minus 5. So 7 minus 13, that's equal to minus 6. Minus 1 minus minus 5, that's equal to positive 4. So this is basically the distance between the ball and the target. You can call this TP. Now, the question is not asking for the displacement vector, the question is asking for the distance. So that means we need to calculate the magnitude. So TB, the magnitude of this vector will be equal to the square of negative 6 plus the square of 4. So the square of negative 6 is 36. The square of 4 is 16. 16 plus 36, that's equal to square root of 52. Now the question has not specified as to how it wants the answer, but if you want, you can rewrite 52 as 13 times 4, and once you take the square root of 4, that's equal to 2 under root 13. And there you go. That is the answer. Let's read the question again. Yep, it's asking for distance, hasn't mentioned as to how it wants the distance. This is going to be in meters. Okay, so the final answer will be 2 under root 13 meters. This is the distance between the ball and the target at t is equals to 7 seconds as the question mentioned. So that's the end of question number 5.